Ever wondered how your computer understands your commands? It's all thanks to programming languages, which serve as a means for us humans to communicate instructions to our computers. They're like a secret handshake, allowing programmers to write code that machines can understand and execute. There are many types of these languages, including high-level ones like Python, Java, C++, and JavaScript, that help us write readable and efficient code, and low-level ones like assembly language that offer more direct control over hardware. So, programming languages are the bridge between humans and machines, allowing us to interact and instruct them. Now, what makes a programming language understandable to a computer? It boils down to two elements: syntax and semantics. Syntax is like grammar. It's the set of rules that define how programs in a language must be written. Semantics, however, is the meaning. It's what your code is actually telling the computer to do. For instance, in Python, when we write print hello world, the syntax is the print function and the string, while the semantics is the command to display hello world. Remember, syntax is about structure, while semantics is about meaning. Let's dive deeper. How do we store and manipulate data in a programming language? Variables come into play here. Think of them as placeholders, holding on to data that we can change or manipulate. Each variable has a name, a type, and a value. But what kind of data can they hold? That's where data types enter the scene. Integers, floating point numbers, strings, Boolean values. These are some examples. Picture Java code with integer, floating point, string, and Boolean variables, each holding different data. Variables and data types are fundamental building blocks in any programming language. How do we control the flow of a program? This is where control structures come into play. These dictate the flow of execution within a program, allowing us to make decisions, repeat tasks, and manage program flow based on certain conditions. For instance, in C++, we might have an integer x set to 10. Using an if-else statement, we can print out different messages depending on whether x is greater than 5 or not. Control structures enable us to direct the flow of execution based on conditions and loops. How do we keep our code organized and reusable? Enter the world of functions and modularization. Functions act like a cooking recipe, encapsulating a set of instructions to perform a specific task. They make our code reusable and easy to read. Now, modularization is like the art of cooking itself, breaking down a complex menu into individual recipes or functions. For instance, in Python, we can create a function to add numbers, call it whenever needed, and voila! Functions and modularization make our code flexible, maintainable, and efficient. So, why is understanding computer languages so vital? Well, they form the bedrock of all software development, enabling us to express algorithms, solve problems, and create robust applications. From recognizing different programming languages, grasping syntax and semantics, to understanding variables, data types, control structures, and the power of functions and modularization, these elements constitute the essence of computer languages. Mastering these basics sets the stage for you to become an effective problem solver and software developer. Happy coding!